Okay, great. So we're all set up. We can begin.
Yeah. Okay.
So where were we? Where did we leave off? And where do we continue from? Still on functions, right?
Yeah. But you mentioned that we finished with it. So we have to do a recap.
Yeah. So let's do a recap. Let me just pull up our notes here. All right. So what did we discuss finally? Are these notes up to date?
You're not sharing your screen.
Oh, I'm not. My bad. I hope you can see my screen now.
Yeah.
Okay, cool. No, it's alright. Is this okay? Can you see this very well, or should I zoom in one more time?
Yeah, I can see.
Okay, great. Super. We were speaking the last time about why we use functions, um, organization of logic, reusability, and abstraction. So if you can recap on the need or the use of functions, then we will set the ball rolling. What did we say about?
Why we need function?
Yes.
In my own words, right? Not in
Yes.
technical terms.
Yes, of course.
Okay. So, but all these ones that you wrote, I said them now.
Yes, but I want to hear you explain it to me. Because one of the ways I would know you understand the concept is if you are able to teach it back to me, howbeit in your own words or not.
Okay, that's fine. So I remember I mentioned that um let's say you want to tell JavaScript to do something or to show you're writing something and you want JavaScript to execute whatever you're writing in the browser for someone to see or for people to see. You want to um you want something to happen when maybe someone clicks on something on their page. Let's say you have a form on a page that you want someone to click. So you want to such that when the person maybe clicks on a button, it's either the button will turn red, will change color, or like will give them a pop-up message or something. So you would want to write a function that would give a pop-up message when someone clicks on a button. That's the first one I remember. And
Okay.
the second one is reusability. So like let's say you're working on a large project and a very, very large project and you might need whatever the function you are writing, maybe you might need it in the subsequent pages or wherever. You wouldn't want to keep repeating all that you have written. Let's say the function you are writing is like a full page. You might not want to go through the stress of repeating that full page in the subsequent project or subsequent pages that you'll be working on. So you might just want to write a function and save it somewhere and probably call it in the next projects that you'll be working on.
Okay.
And for the abstraction, I don't remember. I don't think I said abstraction.
Yes, so abstraction, we are saying it's hiding away the details. So
Yeah,
providing a very simple, or what looks like a very simple surface to a very complex underlining of something, or a piece of logic, right?
yeah,
Remember when we said send birthday message, the function? Let's say this is a very complex function, but it presents as send birthday message. And when you import and use this, all you need to provide is two arguments, and then you get whatever results send birthday message returns. And you don't have to know about the complexity that's lying beneath that. So that's
okay,
abstraction. So it's like when you use the React library, it's a lot of complexity that's going on under the hood. Like if you take time and you read the React source code, you'll be like, what's going on? But when you use it, you just realize that you are just importing functions, and then you are providing arguments, and then you are going your way. Things are re-rendering, things are updating, you are using state, but it's a lot of complex code that has been executed or that has been written behind the scenes. So that's abstraction, hiding away the complex details so that your program begins to read like a letter, like just normal English language. Instead of
okay.
instead of exposing the implementation details and then spitting up all these things on the surface, you abstract them away nicely, not just for the sake of it. Um, you abstract them away because they perform a function. That's why they're called functions. All right. You abstract them away nicely. They do only one thing, right? Send birthday message sends only a birthday message to name on their birthday, right? It doesn't send them a birthday message and wishes
Mm,
them Merry Christmas at the same time, right? So those are some of the things we'll be looking at later. Like I said, the foundation has already been laid since you understood or you're understanding functions in programming, JavaScript specifically, but the rest will be about some of the conventions, some of the best practices that go with using functions, right? So it's just like, okay, now you have learned the semantics of, let's say, the English language, but how to express yourself, it's a different thing, right?
yeah,
Yeah, so
yeah.
those ones come with experience. Like, okay, the more we go forward, then you'll begin to pick up these things one after the other. So don't fret. We are getting there slowly. So that's great. That's good.
Okay.
So today I would like us to look at a few more things about functions, and let's see how far we can go with that as well. There are some other
Okay.
things that you need to know about functions. So let's start with arrow functions. You may have seen them in the code you write. You may even use them sometimes, but you probably don't know what's going on. So do you remember the types of functions we said there were in terms of names or naming?
Types of function in terms of name.
Yes, we said there are two types of functions in terms of their names or in terms of naming.
Remind me. Say one and then we see whether I remember.
Okay, anonymous functions. Let's see if we have the notes here.
A.
Oh, we didn't define those. Let me see if we have the notes here. Maybe I
I'm
may
not
have.
sure.
Okay. Maybe I may have said it in passing. Let's see here. Oh no. My bad. I didn't mention
I'm
that to
not
you.
here.
Yeah. Okay. Then let's look at it then. Before we jump into arrow
Okay.
functions, let's look at types of functions. I shouldn't just say types of functions broadly because there may be types of functions or there are types of functions in other categories, but let's look at types of functions in terms of their names. So when it comes to naming functions, there are anonymous functions, meaning functions that don't have a name. So what was the formula we said for defining a function? We said the keyword, the function keyword, the name, parentheses, and then parameters, optional parameters in there, right?
Yeah.
Function definition or declaration.
Yes.
Yes,
Function signature.
exactly. But that was named functions we were discussing. So named functions, obviously functions that have a name or names. That was,
Okay.
yeah, the one I mentioned or the one we looked at all this while when we were discussing function declarations, named functions. So now let's look at anonymous functions. With anonymous functions, functions that don't have names, you omit only the name part. So the function keyword comes, then immediately the parenthesis follows. Right, so compare this declaration to this. Right, so let's say name here. This is the parameter that it takes, or let's say greeting. So, right, so you see that the only thing that is different is the name. It has no name, just the function keyword, and then the parenthesis follows immediately. So
Yeah.
um, so let's console.log. So now let me use name here because we are going to say hello to name. So we say hello name, right? So from your um, understanding of functions, if we don't give a name to a function and we declare it, what is the observation you make right away? Any observations about anonymous functions as we have declared them here so far?
Nothing has happened yet.
Okay, let me go a bit further and you understand what I'm saying. So here we have a function. Two steps involved in using functions. First you declare them or you define them, then you invoke them, not so?
Yeah.
But now we have declared one, it has no name. How do we invoke it? Because when we looked at named functions, you needed to invoke it by name. You needed to call it by name. So now that this one doesn't have a name, how do we invoke it? Yeah, that was the observation I was talking about. So that's the thing with anonymous functions. They don't have a name, so you cannot use like the name as we give in the case of named functions to invoke it, like sum of two numbers here, and then we invoke it here. So if that's the case, then why do we have anonymous functions at all, or why do we even need them at all? Two things here. We can give, in quotes, a name to an anonymous function by assigning it to a variable. Look at this closely. I know you have not seen this syntax yet so far. If we define an anonymous function like this, two things will occur. If it's like this, it's pretty much useless. We have just defined it and we have lost it because we can no longer refer to it. Are you with me?
Yeah, I'm with you.
Yeah. You remember when we were discussing variables, we said the reason why we assign things to variables is because we want to be able to refer to them later. Like we gave in the refrigerator analogy. If you pack things nicely in the refrigerator into containers and label it, it's because, for instance, when you ask someone, go and fetch me some milk from the refrigerator, they can go, and then using that reference, they can go and retrieve exactly milk from the refrigerator. They're not going to retrieve water
Yeah.
because you gave an explicit reference there, right? But let's say in the kitchen, like we said the other day, in the kitchen there are two containers which have salt and sugar. Without any reference or without any labels on those containers, we cannot retrieve either the salt or the sugar because if we wanted to retrieve sugar, we might retrieve salt accidentally, right? So the reason
Yeah.
why we assign things or we name things in terms of giving them or assigning them to variables is because we want to be able to refer to them. Now, this anonymous function here is two things here. One, to be able to use this, meaning to be able to invoke this, we could wrap this in parentheses like this, and then invoke it, because we already learned that to invoke something, you bring the parentheses and then you provide any arguments that were in the function definition or declaration. So it's same thing we are doing here. We are wrapping it in a parenthesis to signify to the compiler that we are treating it as its own expression. And so this type of function invocation is called immediately invoked
Invoked function.
function expression. So let me just make sure I'm getting the acronym here. Yeah, immediately invoked function expressions, so IIFEs. They are anonymous functions that you wrap into a parenthesis like this, and then you invoke it immediately. Why parenthesis? Because parentheses signify expressions. Like when you are doing math and you had, let's say, 1 plus 3, what do we have here? 1 plus 3 times 4 divided by 10. You cannot execute this expression without wrapping some things in parentheses. So in algebra, I have BODMAS, right? Bracket of division, multiplication, addition, subtraction. You cannot evaluate this expression without having this, having that, right? So putting the values as smaller expressions by signifying them enclosed with parentheses makes the evaluation easier. I don't know if I'm trying to put my point across.
Yeah.
So parentheses, when you come across them in JavaScript also, whenever we want to group something as its own expression, we use parentheses sometimes. It's not very common, but you see it sometimes. I wish I knew I used these examples in some of my code bases. I wish I could just refer to it straight away to show you an example, but it's all right. Anytime I come across it, I will just screenshot it and send it to you.
Okay.
But in some other languages like Clojure, it's even more palpable in that in Clojure, everything is an expression, therefore everything is enclosed in parentheses. Look at this. This is a language called Clojure. which I'm learning right now. These are actually expressions. Like this is the closure language. You see what's going on? Everything
Mm-hmm.
is everything is in so many parentheses all over the place.
And
Because
that's how they are supposed to be rated.
yes, because in closure these are called forms or expressions. In closure, everything is an expression.
Oh, okay.
Yeah. Expression. What's an expression? We already tackled expressions when we did the mathematical representation f of x, right? We said these things are built on
Uh,
mathematical concepts. They are not just in vacuum like that. F of x
yeah.
is an expression because this is not the final value. It evaluates to y. So what's an expression? An expression is anything you can evaluate to get another value, right?
Okay.
And how do we evaluate functions in JavaScript? We call them or we invoke them. So by wrapping the anonymous function here in parentheses, it becomes an expression. And so now we can invoke it to evaluate that expression in order to see what comes out. So here, let's go to our browser and then try to see an example for ourselves. So if I just pasted that statement there, so now you see that in this case, the anonymous function is actually taking or actually defines a parameter, right? So in the invocation, in the parentheses for the invocation, we must also actually provide that parameter. I don't know, can you see this? Forgot to zoom in. You can see
Yeah,
this
I can
clearly.
see.
Yeah.
Yeah.
So the anonymous function takes or defines a parameter here. So in the invocation, we must also provide it. It's the same thing we do with the named ones, just that this time it has no name. So in the IIFEs or immediately invoked function expression, we wrap it in parentheses, and then the other parenthesis is for the invocation, just like we have in the named functions. Is it making sense?
Not really.
Okay. So let's take it from the named functions again. What happens
Okay.
when we want to do named functions? First, we define, don't we? Or we
Yeah.
declare. Here we declare a function called send birthday message, takes two parameters, date of birth and name, right?
Yeah.
And to use, I've always been using the word use for a while now, but I am progressing forward because now we are going deeper. To evaluate
Okay.
this expression, we have to invoke it.
Mm-hmm.
Formally, to use this function, we'll have to invoke it or we'll have to call it, don't we?
Yeah.
And how do we call it? We say the name and then we bring parentheses and we provide the arguments in the same order as the parameters were defined. This is understood, right? Solid.
Yeah.
If it has no arguments, like in the case of say hello here has arguments. Which one did we define that doesn't have arguments? All of them do. Anyway, if it has no arguments, like say we define one and then we goes, then right, this one has no argument, so all we do is we say the name. It makes sense, right? If you want to call somebody, you call them by their name. So same thing here. Functions, you call the name, then the parenthesis to signify that you're actually invoking it or you are evaluating it. This is understood, right?
Yeah.
Yeah. So in the case of anonymous functions too, they don't have a name. That's the thing. Anonymous, no name. Anonymous means without name, right? So how do we call something that doesn't have a name? It's impossible to refer to something that does not have a name. Is it
Are you
not?
sure?
Maybe you refer to them by hey or something, but if they're in
Exactly.
a crowd or something, you may not necessarily know. Like this anonymous function here is in a crowd of other named functions. So how, if you refer to it by hey, how will it know that you're actually referring to it? Right? So you approach
Yeah.
this in two ways. This is the first way we are looking at. We are saying that you do this immediately invoked function expression, which is after defining, so let's start from the beginning here. After defining the function, you wrap it in parentheses, then it becomes an expression, just like this one, but it doesn't have a name, right? So now all you can do is to invoke it immediately. That's why immediately is here. So you define it and then you invoke it immediately in the same block of code, as opposed to these ones where we define it somewhere and then later on we can even invoke them as many times as we want. Are you seeing the difference? This one we can invoke even at the top of this file, and then down somewhere we can invoke it as many times as we want. Anonymous functions, when used as immediately invoked function expressions, we don't have that luxury. As soon as we define them, we must use them immediately. That's why immediately is here. So in the same code block, we just wrap it in parentheses, and then the other set of parentheses, which is the one we use in invoking, like this one is for invoking, the yellow parenthesis here. We provide the same thing here. So this is the part that accepts the arguments. So same thing here. This is the part that accepts the argument. So here we'll provide the arguments that this function definition requires, which is the name. So let's see what happens here when we do it. We get hello Alfred, because this function definition was taken and then immediately invoked with the argument we provided. Now this seems abstract. I understand you have a question, like you probably have a question like, in what instance do we use this immediately invoked function expressions? Because I have not come across in this thing while I'm writing code in my short period so far. and you would be you'll be making an absolute valid statement. Now
And
you may.
also, what happens if you don't immediately invoke it? What happens?
So what happens if you don't immediately invoke it is, first of all, I told you two ways of handling this, right? So we are just looking at the first way. But
Okay.
in terms of the first way, which is the IIFEs, if you
Yeah.
don't invoke it immediately, you have effectively lost it. There's no way
Mm,
to get a hold of it back because you don't have a reference. Does it make sense that you have effectively lost it because you don't
not
have a
at
reference?
all.
Yeah, because like in programming, if you don't bind an expression or a value to a name or a symbol, which we refer to here as variables, there is no way to refer back to them. So, like I started telling you, the deeper underlining of this is that whenever you declare a variable, you are creating space in memory. We mentioned that previously, right?
Yeah, with it.
Yeah. Another time we'll go deeper into that. But that simply means that this space you have created in memory, you need to assign a name to that space in memory where you are putting a value so that later on you can refer to it. Like the question I'm asking you right now is, how do you refer to something
Without any.
without a name? Right? If you don't label it, how do you retrieve it? Think about a library, right? In the
Mhm.
catalog, if they were ever to have a book which has no name, how do you retrieve that book? Or you just say, go and retrieve the book which has no name. That's effectively how you would retrieve it. Right? But let's say you have several books that have no name. How, if you are the librarian in that library, how do you retrieve? And someone comes and says, I want a book, but I don't know the name. How do you
So how
retrieve?
how are we going to?
You see now. So that's the thing with
Yeah.
anonymous functions. Since they have no names, one way of handling them is as if we invoke them immediately. How? We have already shown it here and here. Wrap it in parentheses and then call it. Now, I said how the use of this you will find in probably older code in the days of jQuery. Now, you youngsters don't know what jQuery is.
No, we don't.
You only know React. Before there was before there was ever a React, jQuery was. Okay? Before there was ever a React that became latest in town, jQuery was king or queen
And we never
ruling.
knew about it.
Yeah, jQuery is a library. It's probably used in, I would say, 80% of websites, maybe more. Let me see. percentage. Let's go percentage of websites using jQuery. Look at that. Close enough. 76% sites. Like jQuery was the tool for abstracting the DOM that we used to build websites, and people are still building or maintaining, I should say, older websites in jQuery. React is what, 10 years plus now probably, but it's still relatively young compared to jQuery.
Are you there?
Yes, I can hear you. Can you hear
You
me?
hear me?
So I was saying jQuery, right?
Yeah.
If React didn't come along, you would have probably been writing jQuery now. But
Oh, okay.
probably some other time we'll look at some jQuery code and then you see how things were like before. Yeah, you would probably see this immediately invoked function expressions in a jQuery code base, right? You may also see it in a script. So for instance, if I wanted to write a script,
Please, yeah, I'm not sharing your screen.
oh, okay. You can see this, yes?
Yeah.
Okay. So for instance, if this was like a script, so let's say, let's save this here as my script, JS. And so if I wanted to just write a small script that's invoked immediately, I'll just do this console.log results. Where does result come from? Result comes from a computation of 2 times 5. I do a series of stuff here, right? So I will wrap all of that, and then I can what? Effectively, so I can node, then call my script, and my script runs because I wrapped my whole logic in a function which I immediately invoked. So the IIFE, the immediately invoked function expression, becomes like my main entry point. In some other languages like Java, there is always a main function. That is the entry point of your application. That's where your application starts executing from. We've not seen any of such code yet, so it may all sound abstract to you, but this is how you might mimic the same behavior in JavaScript, because JavaScript doesn't have or doesn't require you to have a main function. In Java, you must have a public static void main function. Okay. In your application, without the main function, nothing runs, because when you start executing, it looks for the function main and starts executing from there. Anyway, that's just by the way. This is how we might mimic the same thing in JavaScript. And this is just going all the way to show you what might be the use of this IIFE. Yeah. So I said there were 2 ways. That was one. The other way is we can actually assign it to a variable. Say my name here. Yes. I've answered the question you should be asking me by saying yes. So ask the question. What question should you be asking me, you think? Any question that jumps out to you?
No.
Really? It just looks normal to you that we can assign a function to a variable?
It
Because
doesn't.
when we mentioned values here, we didn't mention functions as part of the values.
Mm-hmm.
So how is it that we're assigning a function to a variable? It didn't look
You
weird at
didn't
all.
tell me what it does. That's why I don't even know what to say.
Okay. Now, right here, we are learning that functions are, in JavaScript, objects, actually. And later we'll find out how everything is an object in JavaScript. But let's go slowly. Functions are objects, so they fall under here. Where's values? Values, values, values. So they fall under here. So since they are objects, we can assign them to variables. They are what we call first class citizens. First class citizens simply because the way you treat other values, you can also treat functions the same. What can you do to other values? You can pass them as arguments. So here we might add another argument here. Let me not say callback. Let me say when finished. So when finished is a function in this function definition that after this we can call this. So when invoking say my name, we can actually pass Alfred first, and then the second one is a function we define. Okay, I realize I've skipped too much ahead. Let's go slowly. I was trying to demonstrate to you that functions are first class citizens, and so whatever you can do to an ordinary object, you can do the same to functions as well. You can pass them as arguments, right? You can add a property. You see, it already has some properties, but you can add your own, right? Custom property, something, and it works perfectly. This one is just by the way to demonstrate to you that functions are first class citizens, or they are objects, meaning you can treat it as any other value. So that is why
That's what you mean by
yes. And that is why we are able to assign them to a variable here. And so because of that, we have effectively given in quotes, a name to this function. So here, if we come here and then we did the same thing here, I said in the first instance you could just invoke it immediately via an IIFE. In the second instance, you can assign it to a variable. And so now you can actually invoke it by name. And so you still have hello Alfred here because we have hello name. Are you following? So
Yeah.
what did we do? Because we don't want it to be lost, we assigned it a name so that we can refer to it. So here we are able to refer to it in the same manner as we are able to refer to a named function declaration or definition. So difference of two numbers, we come and we call it here difference of two numbers. So the question that may be coming up in your mind is, okay, so what's the difference between a named function that has been defined this way and an anonymous function that has been assigned to a variable, effectively giving it a name? Is that a valid question? Do you understand
Yes,
the question?
because I'm coming. Because at the end of the day, you still invoke it by its name, right?
Yes.
Okay, so what's the difference then?
Not so many differences.
Okay.
Not so many differences. Because at the end of the day, you have two functions that you can invoke, right? That work normally, just like the named function, right?
Mm-hmm.
But let's look at something here. Not so many differences. The short answer is there are two ways of doing the same thing,
Okay.
right?
So
So
that's just like an alternative.
yes, but like I told you, in programming, we don't do things just for the funsies. There will be a specific reason why you would want to define, let's say for instance, difference of two numbers in this way, a, b, returning a minus b, as opposed to doing it like this. But essentially, they are the same thing. You invoke it by that. You know, when we run this, we'll run into an error anyways, because you cannot have two functions with the same name, right? I'm just trying to show you
Yeah.
that instead of doing this, you can also declare or define difference of two numbers like this.
Yeah, I get that.
Yes. But look at, let's see if I remember correctly, if this is a difference. So we have a function defined as a named function, difference of two numbers. So when we say difference of two numbers dot name, that's a property on the function object. I told you functions are objects. So they have some internal properties on them. So you can see arguments. You can see bind, call as one property. One of them is name. What does
Mm,
name do? Name just returns, or it's a property that is contains the name of the function as a string. So here we are just getting the name of the function, right?
Okay.
But let's try to do the same thing on the one that has been defined anonymously but assigned to a variable here. Let's do a name on it. Oh, it has. I thought it didn't. It has name. Okay. Not a problem. Not much of a difference, like I said. Not much of a difference. Because at the end of the day, it's the same thing. Two ways of doing the same thing.
Now, why would someone prefer the anonymous one to the name function?
So, the use of anonymous functions has to do with mostly, there are functions that require you to pass, or there are functions that define parameters that are other functions. What I mean by that is, if you have an array, right? 1, 2, and 3, like this. All arrays have a property called map on them, right? What is map? When I did dot map, you can see that map is a function. Map is a function which takes another function as an argument when you are invoking map on any array. So that means in map's definition, now map is an internal function that comes with JavaScript, right?
I can't hear you anymore. Can you
Not
hear me?
anymore. Why do we keep losing sound?
I don't know.
How about now?
Yeah, I can
Loud
hear
and
you.
clear. Okay.
Yeah.
So map comes with arrays internally, right? But let's try to remake map here. That means that map, when it was defined, takes a function. Let's say func. And then what happens is that map says any function that you provide here as the argument, I will call that function on each of the elements in this array here, one after the other. I know I'm pushing a bit forward, but I'm just trying to demonstrate, demonstrate to you why or how functions can be passed as arguments to other functions. So far, we've seen us define functions where the values are just strings. The parameters, I mean, are strings. Other times numbers, right? So difference of two numbers. We pass two numbers. Say hello or birthday, send birthday message. We pass two strings, right? But for instance, let's alter this function definition here. We could actually pass a parameter which should be a function. Why do I say should be a function? We are expecting a function there. So we can pass a parameter, let's call it, I want to give it a descriptive name. So when finished, let's say after sending message. So in this definition, after doing all these things with the after sending message, we can call, excuse me, after sending message, so that now send birthday message requires 3 arguments. The third argument, what is it? It is a function that we are supposed to pass as the function definition. So here, if we say birthday message sent, this string is a value. John, the string is a value. This function definition here is a value. Remember, we said functions are values. That's why we can assign them to variables. So, if one function, send birthday message, is being defined, date of birth is a value, a string, name is a value, a string, after sending message is a value, a function. Therefore, when we invoke send birthday message, or when we call send birthday message, we can pass this date, a string, this name, a string, and a function, the function definition. This is one of the uses of anonymous functions. This function here, we don't necessarily need to give it a name. We can, but it is inconsequential. Inconsequential name. Because we are passing this function definition as the third argument here, which the previous function send birthday message will call after executing the piece of logic that comes before. Practically, this is what it would mean. Okay, so let's leave map for now, and then let's try to understand why or how functions can be passed as arguments. So send birthday message has been defined. Let's now invoke it here. Let's see what happens. What happened to our after message? Yeah, today's date. Oh, okay. We did an if statement there. Send birthday message, right? Let's keep it simple. Remove this. All it does is it says hello to, okay, now hello has not been defined, so let's just console.log normally hello, otherwise we'll get an error there. Hello name, Then it says today's your birthday, have a good one. Okay, this is coded language. Let's not expose it. Okay, I see what was amusing you now. Okay, code. All right. So after sending this, or after doing that, then we say we'll invoke the function that was passed to it as the third argument. So now, if we try to call this now, we pass something, and then we pass a name. Let's use John. We are seeing as the third parameter, it's expecting a function, right? So in this function, you can do whatever the after sending message, whatever you must do after sending a message. So here I just want to console.log birthday message sent. So here's what happens. Hello John, this is it. Today is your birthday, have a good one. This is it. And then you see there's another console.log saying birthday message sent. Why? Because in the function definition here, we received another function as the third argument, which we called. Do you see that we are calling it? We are calling it there. Right? That is, and then in the function definition of that function call, we are having birthday message sent here. Another way we could do this was that anonymous function, we could have assigned it to, let's say, what to do. Then we'll have it right, and then we'll say alert the caller that the message has been sent. Right? We have a function which we have assigned to a variable what to do. So if we are calling send birthday message again here, and then we pass the date of birth, right? So let's just pass something. John. We can refer, you see, now we can just pass this reference. Variables are for reference or referring to things. So this thing is a container that's holding, what to do is a container that's holding this anonymous function. In the beginning, we just passed it directly here. Another way is we can assign it to a variable and then pass it as the third argument here. So when we execute this two, it will say, hello John, today's your birthday, and then it will show this console.log from this function definition, because in the send birthday message function, we are invoking that third argument. Ask me questions about why passing functions as arguments is not clear, because I know it's not clear. it looks weird because they are functions. But the moment you accept in your mind, all right, or you come to a realization that functions are values just like any other value, then all the confusion disappears. We need to settle this in your mind now, so that if it's settled in your mind and you go back to your React code, like something just jumps out to you all of a sudden that hasn't jumped out to you previously. You begin to see things that you'll be like, it's my own code, but now I'm seeing new things. No, it's because things are now making sense. Because formerly, perhaps you would see a function being passed as a prop and you didn't know what was even happening. This is what was happening. When you are declaring or you are defining a function, you can expect one or more of its parameters, even all of them, to be functions also, which you can invoke within the body of that function. So you can pass around functions as parameters or as arguments, depending on the context. Just like any other value. Only thing is, with functions, what do you do with functions? You invoke them. So this function definition here makes sense. It says send birthday message. Now, to the one who is calling send birthday message, we want you to be able to, we want to signify to you that we have finished sending the birthday message. Maybe the birthday message takes time to send, as we'll see later. Now, you saw in the beginning, I started writing this as callback, then I refrained from doing that because I wanted to explain to you by giving it a meaningful name. Usually, a pattern arises where in JavaScript, you define a function that does something. Let's say it takes time to do that thing. And then after the thing has successfully completed, you want to... What was my last word?
I didn't hear you.
Okay, but you can hear me now.
Yeah, I can.
So I was saying that you remember I wanted to call this parameter callback, then I refrained from doing that, and then I gave it a rather meaningful name to explain something to you. Do you remember? Yes. So in JavaScript and in Node.js, there's this pattern called callback functions where you, in your function definition, you are performing an action that probably takes time, and we'll look at some of those functions soon. For instance, retrieving something from the database or making a network request to an external API. Those things take time to complete. So far, we have been executing functions and then things are happening instantly. It's good, but it doesn't always happen like that. Things are not always instant. Some things take time. Let me show you an example of something that takes time. When you are even visiting a website, let's say this one may take a split second to come, but it still took time, didn't it? Because if you watched my first video on what is the internet, you realize that the process that the browser goes through is quite a number of steps. Let's go and see a breakdown of those steps while we even have the information here. We said that it takes time, but it occurs so quickly that you don't even realize it. What happens when you enter a URL into a web browser? I have defined about 6 steps here, right? But it happens almost instantaneously, but it does still take time. And this issue of it taking time will be more palpable when perhaps your internet connection is slow. Have you tried to load a web page with a very bad internet connection before? So effectively what I mean to say is that the body of this function
You're
perhaps...
no longer sharing your screen.
Oh, wow. Okay, I dropped first. Yeah. So the body of this function... Oh, I wasn't sharing when I was showing the blog, you were late to the party. I was showing all these things. You were late to saying you couldn't see it. Okay, I was saying that where I explained how the internet works here, and where I talk about what happens when you enter a URL into the browser, I define about 6 steps here. It takes time.
Yeah, I read it.
Yeah, it takes time. So let's say let's say Instagram.com. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've counted about 12 milliseconds there before we got the web page, because the browser goes through a series of steps. First, it makes an initial request to the server that has the web page. When the page is there, the server responds, then the browser executes that response. All I'm trying to say is that not all tasks or processes are instant when you are executing functions. Like we have seen so far, where we are just console.login. You will not be console.login in your production apps. You will be making network calls. You'll be retrieving records from a database. Those things take time. So for instance, if the send the birthday message was a process that took time because we were making a request to fetch something or making a request to an external service that was actually responsible for sending the birthday message, we want to be able to know when the message has been sent successfully. So we might say, after sending message here, so that in the invocation we want to perform an action when the message has been sent. So even let's have success. Copy this here. Let's have on success and on fail as 2 functions in addition to date of birth and name. What that means is that when this function has completed execution, I'll do something here. Don't worry about the semantics. Just follow the explanation. So in catch, because you have not seen the try catch so far, in catch I will call on fail, and in try I will have the body as what we want to actually try. Okay, that's why I write it in the code editor first, no problem. You will usually be using try catches when you are making network requests or you are fetching from the database, because anything can happen. There might be an error. So that's what try catch is for. We'll look at it later. Try catch simply is try something. If it blows up, catch it here and handle the blow up. That's simply try catch. Right? So that's what I'm saying, that your function may want to try something, and then when it is done, the caller or the one who is calling this function may want to perform some further actions when that function executes to completion or successfully. And on the other hand, it may also want to execute something when it fails. So, for instance, when we call this here, we will hand over the date of birth, we will hand over the name, and then we will define a function that should be executed or should be called on success. So on success, what do we want to do? For now, keep it simple. We just want to console.log, let's say birthday message sent, and then let's say we want to do another action where we tell admin that a message was sent, right? On fail is this on fail part, which we are providing as the last argument. Also a function where we do something else. So here we'll say we need to inform the manager, that birthday messages are failing. This is why we might pass functions as arguments to other functions, right? So in this case, when we execute this, since we don't have any code that throws an error here, it will say hello to the name, it will say today is your birthday, and then it will execute the on success one. There's no error, so the catch block, these parts, the ones within the catch block here, this is called the catch block. The catch block doesn't execute, right? So let's call this, okay, syntax error. Missing, what am I missing here? Okay, let's bring this all back here. We'll be using a better online JavaScript playground soon. Don't worry. Today was not so well planned, but subsequently it will be better. Okay, so here's probably where the problem is. What are we missing? Let me take this out. The message does that. And there's the last one. Okay, this string is not closed. That was why. So here, oh wow. What's now? Okay, let's come back here. Let's put an error. Okay. Oh, I dropped again. All right. We'll close soon. All right, after this one. I hear fatigue in your voice. Understandably.
Sleepy.
Yeah. So here, hello Alfred, today is your birthday. Then the success one call executes this one. The admin message was sent. Right? This one. Right? Let's do another one where something goes wrong. We will purposefully throw an error. So we'll throw an error here and say, oops. Right? So what will happen? The on-fail parts will execute. Because I said try catch is for try something, when it fails, handle it in the catch block. But when it doesn't fail, then we are here, you're in the try block. Right? So the first instance, this one executed. But the second instance, this one will, because we are deliberately throwing an error here to demonstrate. So what happens? Hello, Alfred, today is your birthday, whatever, but inform the manager that birthday messages are failing. Just as we defined in the on-fail one. Suffice it to say that 1. Functions can be passed to other functions as params/arguments, depending on the context. Why might we do that? Because of a pattern that I just demonstrated to you, that a function send birthday message, do something. When that thing you are doing fails, we have another function we want to call when it fails. When it succeeds, we have another function we want to call when it succeeds. So it's like a continuous process. Do your part. When you are successful, let us know. How do you let us know? By calling our success. Like for instance, right now I can tell you, blink twice if you are still awake. And blink once if you are sleepy.
Oh, friend.
Right? So it's like that. The action is what? We are checking for sleepiness. And then on success, blink twice. On fail, yeah, you can't even blink at all because you are sleepy. Right? Same thing here. Same thing. Perform an action. When you are done and you are successful, call the success function, the extra function that we are passing, to let us know so that we can execute something towards that effect or to that effect, which effect being action was successfully performed. Otherwise, you can let us know it failed so that we handle that appropriately. This, in essence, is one way we can demonstrate why you might pass a function or a number of functions as arguments to another function. So, in our next meeting, we will go over this. I know I've introduced a couple new concepts here. One being anonymous
A
functions.
lot of them.
Yes. Immediately invoked function expressions. Then this weird issue of passing functions as arguments to another function. I know how weird it sounds. And I know how weird this code looks. But trust me, it will get, or it becomes easier and easier the more you look at it and the more you think about it. So don't fret. This is just day one.
I hope so.
Subsequently, you will be breezing through these kinds of functions and you will not even remember when they looked weird at all. Be like, wow, this doesn't look weird at all. All right. But we'll look at that subsequently. See you in the next meeting. Get some rest now. Okay?
Alright.
All right.
You have a good night.
Likewise. Bye-bye.